Welcome to this video on clustering and calling your scene with Wallworm. I'm Sean Olson, and I'm going to share with you some techniques and tools for optimizing your scenes for games in 3ds Max. Our goal here is to reduce draw calls by reducing the number of props by combining them or clustering them. Since we're going to do this, it also makes sense to remove or call unseen geometry. We use this technique heavily in the Zen chapters of Black Mesa. In this video, I will show you the techniques being used on some of the old levels that were re-arted after Zen. Using the Viz Group Manager to hide things you're not clustering will help you only see what you need to quickly cluster your scene. In this view, you can see a list of automatically classified types of objects, like entities, that compose auto-viz groups in Wallworm. You can also use this menu for manually classifying your own viz groups. This scene was originally imported from a VMF file from Hammer that an artist used for scattering props and sculpting a landscape. If you are not compiling your levels from Wallworm, you can actually skip hiding objects and delete unnecessary objects instead, which is what we did for much of Black Mesa. I'm demonstrating the use of viz groups for a pipeline that keeps the entire project inside 3ds Max. Because we want to call the geometry to the landscape, remove any geometry hidden by the terrain, we're going to create a displacement proxy. The reason we want to do this is because actual displacement should not be used in boolean operations. I'm not going to get into the reason for that, but just remember that I said it. Every displacement is used in the displacement proxy. After adding a generic red material to the displacement proxy, you're now ready to open the convert scene to model floater that will be used to cluster and call the scene. Because it will be used at all times, you can dock it to the side of your viewport. One last thing before you can proceed is to hide the actual displacements, which you can easily do with the Viz Group Manager. Now take time to set some default properties for your clusters in the Convert Scene to Model tool. This includes setting a path for them to export to, surface properties, opacity, etc. Each cluster you make will get these settings applied to them automatically. The next step is to set up the calling mesh. Select the displacement proxy in the scene, and below the calling objects list, click the Add Selection button. Next, select some props in the scene and click the Create Bounding Around Selection button. Next, turn on Auto Bound, then select your displacement proxy and right-click the Call button. It's important that you right-click this button because it adds more appropriate functions that are used more often. In future versions, it may always do that in all functions, but for now, right-click it. Now the displacement proxy will always be truncated to a region specified by the current scene selection. This greatly reduces calculation times for the calling process. Notice that the scene selection changes, the landscape adapts in size. Here you may want to use more objects than just the landscape for calling, so you can temporarily turn off the Auto Bound button, select the objects you want to use for calling, like the walls, and press the Add Selection button. If you want to proceed by only being able to select a certain kind of object, you can use the selection filter. In this menu, you can even use specific types, such as a source model, which is the geometry type used for all the rocks in this scene. This will keep you from accidentally selecting other geometry classes while you go forward selecting things to call. Now you might be eager to proceed. You might start selecting objects, turn the auto bound back on, and start calling. But wait. Inspect the meshes. If the models are not properly designed for Boolean actions, you will have a miserable time. Notice these models that have holes. The back faces are gone. These will cause problems. You need to make sure that you have models that do not have any open borders. All vertices should be welded and there should be no self-intersecting faces. The most optimal solution is to recompile the source models with these issues taken care of so that new scenes will automatically get the fixes, but in this case, we will be taking care of the problems inside this scene. So that you can easily reselect a set of objects, you can add them to a named selection set. Here I call them set 1. Now select one of the models that is bad, turn off the selection filter so you can select other geometry types, and in the Modify tab, click the button that says Create Substitution. When prompted to apply a modifier to all models using the same MDL, click Yes. What happens now is that an editable poly object is added to the scene using the current model's mesh, and a substitution modifier pointing to that new editable poly is added to all models using the same source model. You can use the Open Edges X view to see problems with the unwelded vertices and open borders, as you can see here in the green. Now with this substitution mesh, we can edit it in a way that allows us to have no problems. In this case, I capped the border and then added a turn to poly modifier to the object. You will repeat this process for all the source models that still have Boolean issues. While some models are very quick to cap holes, others take a little bit of thought. Notice the L-shaped open border on the back of this rock. If you simply use the cap holes function, you will likely get a very oddly shaped polygon that is bad for Boolean functions. To fix this, you want to manually place a polygon connecting both sides of the rock that will break this single open border into two borders. This is a fast-forward sequence of making several substitutions in the scene. In a scene where the same set of source models is used repetitively, most of your cleanup will likely happen at the beginning, as each new set of models you cluster will likely contain source models that you already fixed with these substitutions. This level took about an hour and a half to clean up and get into the game engine. Select the models again, and you can start clustering. Turning on the display selected with edged faces on makes it easier to see what geometry will compose any given cluster. Inspect the selection. If it looks right, we're ready to go. Create an appropriate model name that your cluster will use. Note that you only need to make a base name. The clustering process will then number them successively. Also, choose a layer to which to move the clustered props. This is a convenient way for managing your scene by keeping your cluster separate from the original geometry. Inspect your selection, and if satisfied, click the Do It button. The first attempt failed. There are many possible reasons for this to have failed. Instead of finding the bad prop, you can also choose to make a smaller cluster, which I did here. Click Do It, and it goes through. This smaller cluster succeeded in turning 6 objects of over 25,000 faces into one with only 13,000 faces. While all the faces inside the object and in the terrain are called, there are still many faces we can manually delete. Spend a little time deleting all the faces the player will never see. After deleting those extra faces, the cluster gets down to around 7,500 faces in this example. Once you are finished editing the cluster, make sure that the results menu is set to Hide Accepted. This will make sure that objects in your scene that are already clustered will be out of view. Click the Accept Last button to finish this cluster and move on to the next. Now enjoy some music by my brother Eric Olson as the rest of the scene gets clustered.